Good afternoon, and welcome to today's editorial webinar on Becoming a Tablet Pro, How to Optimize Downtime. My name is Karen Langhauser, and I'm the Chief Content Director for Pharma Manufacturing, which is producing this event. This event is part of Pharma Manufacturing's Thought Leadership Series, which consists of several editorial-driven webinars on important industry topics throughout the year. Today, we're going to talk about solid dose manufacturing. The key to improving the tableting cycle and reducing defects lies in three variables: the tablet press, tooling, and the final blended formulation. Success and failure can be found in all three. In this webinar, we will outline and discuss how to optimize in order to achieve overall tableting success. The approach outlined in this webinar is geared towards improving performance of your manufacturing team, reducing downtime, decreasing the number of defects significantly, and increasing productivity. To complement this discussion, we will have a live audience-driven Q&A session at the end of the presentation. So please submit your questions as they occur to you. Before I introduce our speaker, there are just a few housekeeping issues that I need to review. On your screen, you should have four primary sections. The upper left or audio section allows you to adjust the volume. Just hover over this section until you see the audio volume control to adjust it. Below that is the Ask a Question box. Not surprisingly, this is where you can ask questions. At any time during today's presentation, you can type your question for our presenter right here, and we'll get to it during our Q&A. And if you're having technical problems, simply type your concern in the Q&A box, and one of our super smart technical engineers will come to your rescue. Underneath the Ask a Question box is our handouts area. Here you will find additional information available for download. In the largest section, you will see today's presentation slides displayed. Below the slides, you will see a live chat box. You can have a friendly chat with your fellow webinar attendees using this feature. Please do not put your presentation questions in this area because I will definitely lose track of them. If, like most of us, you are over 40 and can't see the screen, you can enlarge a section by clicking on the tiny box in the top right corner of the section next to the X. If you accidentally close out a section, don't panic. You can get it back by clicking the refresh button at the bottom of the screen. It's the swirly arrow thing located on the far left of the icon. This webcast will be archived. We encourage you to direct colleagues, friends, strangers on the street to the recorded presentation. It will be available on the Pharma Manufacturing website. We've also recently added a Q&A feature to our on-demand presentation so that listeners can still ask questions, which will be passed along to our speaker. Just when he thought his job was done, we will continue to ask him questions. And one final note, we ask that you respond to the feedback form at the end of this presentation. Your answers will help us to improve future events. And now it's my pleasure to introduce today's speaker, Mike Tousey. Starting as a machinist making tablet press tooling and rebuilding tablet presses, Mike has a long history with manufacturing and packaging equipment. Mike founded Texuticals in 1989 and since then has been troubleshooting solid dose processes and training people around the world to operate and maintain tablet presses and solid dose equipment. On a more personal note, Mike is also an active member of Pharma Manufacturing's editorial advisory board and has been our tableting technology tour guide at many industry trade shows. Our editors had the opportunity to attend one of Mike's solid dose training courses last year and found the course extremely informative, which is why we specifically asked Mike to be our speaker for this thought leadership webinar today. Mike's time and expertise is highly sought out in the industry. This is a great opportunity to learn and ask him questions. With that, I will hand the floor over to Mike.
Well, hi, Karen, and thank you very much. It's such an honor to participate in this event, and thank all of you for attending. This is a big topic, talking about how machines work and how tooling, the features of tooling and how they work and the demands of powders and performance of products for tablet making. And so I've broken this down into the things that we must focus on to assure that we have a fighting chance at quality in manufacturing. So thank you, and off we go here. So the ability to produce tablets at a maximum output with quality limits throughout the entire batch is performance. It's really what we're about, and so I have to look at things, the metrics, what drives everything to make it happen. The formulation or the ingredients and how they perform, and the tooling, and how that impacts what the tablet we're making. The press, how it's set up, how it works, the auxiliary or ancillary machinery, the dust collection, how long it takes to change over equipment, and what that means, what cleaning is really about, the documentation, the skills of the team, and all the scheduling that has to fit into it to make everything work. So all of these things are what we're going to blend into this presentation. And I really want to start with the procedure. I really think that if you look at what I've got here, which is basically traditionally 3 of those components are typical to many companies. And what I'm talking about right now is performance versus survival. So a company that survives is stressed, and it's all about, let's get this machine set up, let's get it operating, and if it's not operating, let's clean it and get it set up, and let's push. And that's good. That's demand. That's making good use of machinery. But if you look in the middle of these bullet points, I've got a couple that the companies who really perform versus companies that just survive perform these items really, really well. And that is, so how procedures are written, how standard operating procedures are generated really is, it's all about how well you set up a machine. And operation of that equipment, making the tablets, getting the product to flow, compress and eject it, to do the things we need to do to make a quality tablet, you had to set it up right. And when we're done operating and we've cleared the room of product and we're about to really take the machine apart, there's 3 things that go on here: the disassembly and inspection, the repair or the replacement of parts, and preventative maintenance. These 3 items set performing companies apart and ahead of somebody who's surviving. A lot of people skip or take that shortcut and go, well, we probably don't need to do everything this time, and that's when we get in trouble. So I really believe in following this procedure. Excellent disassembly and inspection of parts means that we're going to be able to perform, and when we're done cleaning, we can set up with reliability. And if we can't set up with reliability, we can never achieve operation. So that's what this focus was about. And when I think of changeover, I think of these race cars and these pit crews that the car pulls in just a few seconds they've performed all their tasks, and that car is back on the track. It's incredible. But if I go into manufacturing, that's kind of what I want to see. I don't want to see the machine stop and then we wonder where the tools are for cleaning, the tools are for taking the machine apart. We wonder who's going to be involved in this process, and so it's really not a team for performance here. It's a little scattered, and that's kind of more normal than really having optimized performance when you're down. Because in my mind, if the press isn't running, if we're not making tablets, then we better be working on it. We better be cleaning it. We better be inspecting it. We better be working on it to get it back to running. And so it can never be left alone. And we have to have the ability to clean really well. We need to make sure that any parts that wear, and many parts on a machine, as I'm going to go into in a moment, wear parts, need to be inspected all the way along. And I'm going to show you some of the things I'm always looking for. Maybe some of my examples are extreme, but I'm going to show that. And then we're going to talk a little bit about the necessity of constant maintenance and the efficiency of setup. So So lots to do here, and I think the reason I'm doing this the way I'm doing it and talking about making better tablets is that if we can outperform in our setup, outperform in our inspection and our repair, we can really perform better in operation. This picture entitled "Metal Fatigue" is just to prove one thing: is that there's. I want to make sure that it's really clear that we call parts on a machine, including punches and dies, tooling, tablet press tooling. This is the head of an upper punch on a tablet press, and that pothole in the middle, metal fatigue, occurs as a result of continual compression of granulations between the pressure roll and this head surface, this head flat on this tool. It's like a pothole out in the road when you're driving. It's metal fatigue. It gives away. It's a wear part. This is extreme, but this is what we're looking for. These are things we need to identify. If that's an upper punch, that metal is going to end up in the tablet. So most machine wear gets caught way before this. But my point here was simply to let you know that normal wear, this is part of normal wear. Normal wear comes from the abrasive characteristics of powders, and all powders are somewhat abrasive. So that's our challenge. The pressure rolls that meet the surface of the heads of the tools is the mating part. And so anytime you see an area of wear on one part, you look to the mate or the contact part that it reaches. And in this case, I'm showing a photo of a pressure roll. They also wear out. And maybe this screen is a little bit difficult, but I have 3 pictures here: bottom left, bottom right, and in the middle are 3 different problems. Some of the bottom left, that happens from the lower punch being tight. A lot of ejection force from trying to push the tablet out, maybe from not having a good blend, maybe from not having a clean machine, maybe from having wear or some damage to the tooling. It could come from a number of things. The one on the right, is a different form of that, often from tight punches or high ejection forces too. The middle one, hopefully you can all guess what's going on there. It looked pretty clean, doesn't look like a lot of damage, but there's an extreme amount of lubricant on these tools. And that actually attracts problems, because excess lubrication means that the free airborne dust gets on this granulation. It is going to distribute itself. It's going to potentially turn into black spots and get on my tablets. So excessive lubrication can be as bad or worse than not enough sometimes. And so we need to be careful of this and assess each stage and step in our setup. The abrasive characteristics or nature of granulation is tremendous, and every batch, every different blend, every different combination of ingredients has different levels of abrasion, and so that demands constant visual inspection every step of the way. And if I didn't express it well enough before, my point is that when you take a machine apart, when we take a machine apart, when we're training our team members, if we really want to make a better tablet, if we really want to get best performance, we need to inspect as we take a machine apart. That way we know what to do to these components before we put them back together, so that we know when we're running what to expect, what kind of heat we're going to generate, what kind of defects can come from this. Because if we generate heat, or we have lots of fines like this, we can end up with different defects. So when I see something like this, and I see where the punches can be tight and I can generate heat, I can create or really cause more sticking. When I see fines like this, I also think, wow, there's a lot going on here that could have a lot to do with delamination or capping issues. So, and the wear of those tools, how long will they last? How how long can I expect them to last, and then the impact of that wear on the quality of my tablet. Not to mention the other end of tooling. So this is just an exercise here in inspection. These are the same thing we're talking about, the heads of a punches and the surface of a pressure roll, but these are not from bad cleaning techniques. These are from a formulation that really wasn't prepared right. That is, that in the preparation of powders, we call the addition of a lubricant, a mold release agent, like the magnesium stearate or other components. And if they're not blended in right, if they're blended wrong, if they're put in at the wrong time, where you see it is in the performance of the tooling, not just the tablet. So this picture is telling us a story. It's sending a message, and it's up to us to interpret it. When I see discoloration, that means there was heat generated. That means there's higher ejection forces. That transfers the problem onto other surfaces of the machine. So the lubrication, or what you'd want to jot down here, is a better word for lubrication. In this case, I'm talking about the lubrication within the formula, not necessarily just the lubrication on the surface of these tools. So the lubrication in the formula really should be called a mold release agent, so we could clearly understand the difference between the lubricant to oil the punches and the lubrication within the formulation itself. So I see at ejection, when the tablet comes off the machine, there's such a variety of takeoff points on tablet presses. And, you know, when the tablet comes out of that die, it expands. And we have to make sure that lower punch is in the right position. And that tablet, when it contacts the takeoff blade, there's impact there. And this picture on the left, where you see the head of a screw, is a much older style machine, but many of them are still in use. And if you look close at that screw head, there's contaminants there. It's got a rough edge. If that tablet hits that, or some of those components fall off, so that's not good inspection. We're not set up for robust operation here. This is, again, survival, not performance. That's what I'm looking for. You know, if we don't set up right, if we really don't know how to properly line tools, or we try to shortcut it. What I mean by the shortcut is one of the most common problems in manufacturing, especially within management and between management and operations folks, is how long is it going to take you to change over that machine? You know, how long, Mike, how long should it take our guys to do this? And every machine, I'd love to be able to just say, yes, it's going to take you 12 minutes per station, but that's not the case. The answer is that depending on the age of the machine, how that machine was built, the clearances on the tooling, the intricacies of the tools, the skill level of the operator, and the tools at hand, you know, combined with your protocol, your documents, your procedures. So when you put all that together, it takes time. My whole point here is that when a supervisor gets a message from management that we need to manufacture faster and we need our downtime to be shorter, oftentimes that message that's sent to the front line, to the operator on the floor, that message comes across as hurry up and take shortcuts. And that's really not the message. The message should be to be efficient, to have the right tools, to make sure that we're doing everything we can so they can do the job professionally and accurately. But don't send the message to take shortcuts, because we get metal. We get metal from lots of things: mills, feed frames, or scraper blades. You know, and so the question always is, when do we change a scraper blade? And some companies will only change it every batch. I think the right answer is, for any of these things, is really when they need to be changed. I think one of the things that we can learn from inspecting machines properly and looking at them is we know that parts are going to wear out. So we need to establish criteria for when and put the operator in front of making decisions on when those parts get changed, or at least make them part of that process, because using a time frame isn't always effective. I'll talk about that more in just a second. Tooling can only take so much pressure. All punches and dies have a limit. Make sure to observe that limit. I know there's lots of setups out there that this is one of the most commonly misunderstood features of a tablet press is called tonnage or overload or protection of the tooling. And it's based on each particular design of the tip. And in this particular case, the tool failed, and we can make any tool fail by putting too much pressure on it. Every different tip has a different limitation. You need to know what that is. A lot of times I'll write that on the punch box for my technicians, so when they set up the machine, they know how to set it up. So these parts, this is quite a picture here. These parts I was in manufacturing trying to figure out why we're having tablet quality problems. I'll tell you what, if you put this machine together with these banged up parts, I think you're going to expect problems. I know you're going to expect problems. So this was these parts came off a $650,000 machine. It's kind of mind-blowing to see parts piled. This was coming back out of the cleaning room, so they're clean here. They've all been moved through the whole process, but I should have taken the video here, because when the guy turned the corner, you could see some of these parts have gone through a crash before, and so if we don't handle the parts right, how well can we do a setup? So if the parts are compromised someplace in the process, and normally parts like these hoppers, chutes, feeder bases, all these things that we see here, these are not parts that wear on the machine during operation. So any of the marks, dings, dents, all these problems here are self-inflicted. And so if the topic today is about making better tablets and having quality, so if I don't set up right, if I don't handle my parts right, I can't possibly perform correctly. And not to pick on experience, but I know a lot of the people in this room had over 20 years of experience in and around machines. So if they're that experienced, then this shouldn't have happened. This shouldn't be like this ever. So I believe that training should be, it's a word that's just thrown all over the place, and we need to be specific about why we want to train and what we want to train. One of the things that happens in training and talking about tablets and talking about the processes is getting the words down, definitions down for everything that we're talking about. Instead of calling parts and identifying parts incorrectly, we need the right nomenclature. I think one of the best practices to get better performance off a machine is to review the controls. It's always amazing to me the number of technicians that are running a machine that truly don't know their own controls. And truth be told, they don't really want to ask because they don't want to reveal what they don't know. And I kind of understand that. So let's overcome that. Let's have training sessions that review what the controls are, both mechanical controls and physical controls, and challenge why you would make the changes to the controls, what impact that has on the tablet. I think that's effective training. The third bullet item here, I think, is a huge one. Establish criteria for worn parts. What that really means is when a part wears out, don't throw that part away. Keep that part. Take pictures of that part. Create a list of wear components and when you would replace them. And now you have examples so that when somebody else is being trained or a new manager has to make a decision, it's not so subjective to well, I don't know, so go ahead and run it. Well, that's not a good answer. If you take parts that are worn and you say, okay, at this point we've deemed this part no longer good, don't throw it away. Save it. Take a picture of it. Use that as part of your training. Couldn't drive my message home hard enough. If we want to make better tablets, we want to get better performance, we got to handle the parts right. We have to make sure that we have a system in place, and most companies fail big time here. They don't have a way to fix parts. They don't have a way to deburr the parts, polish the parts, have a place to do it, have people that are trained to do it, and do it effectively. So I think that, without exaggeration, 80% of the companies out there that don't have a system in place to really properly take care of parts. It's just thrown at the maintenance guy, and he still needs the tool to do this. Train everybody to clean. Rule number one. I mean, clean, keep cleaning, because the enemy is the dust. And if we don't control the dust, we lose. And dust is a difficult thing. Okay, so I'm gonna buzz through here. So tooling inspection, critical. I'm asked every day, when should I inspect the tools? And I go, to check working length, to follow TSM, Tablet Specification Manual, you really need to follow these things and do inspections repeatedly. The big thing about this topic right here, head flats on tooling, is that if you look at old and new sets and you see a variation in the head flat, I just want to make it clear that a variation in the head flat has a direct relationship to the hardness of a tablet. So the bigger the head flat, the bigger the tool. So if you have variations in head flat within a set, or you have older sets that you use and newer sets that you use, and you get various hardnesses, that could be one big reason that's often overlooked. Look, during compression, we're trying to get rid of air. Upper punch's tip is smaller, so the air releases. That's what this picture is about. And then when we compress the tablet, we have wear or attrition as a result of making the tablet. So this is a broken die, a die that I broke in half. And it shows where we made the tablet in the top, where we made the tablet in the bottom. And so if we use these right, we can get better performance. If they go that far, it's too long. We have to release air during compression, and using a taper in the die is a miracle worker. It really has a big impact. Polishing, I had a great question the other day. Somebody said, how do I know I polished well? I mean, we're trying to keep a mirror finish. We're trying to prevent sticking. We're trying to keep those tools new. And I think the biggest benefit in polishing every time you go through a major clean is that you're physically forced to inspect these tools very, very closely. That's the biggest reason why I want to polish every time I'm really breaking that old machine down. This is an amazing picture here on the left. That guide, that hole that you see that we're looking down into is where the punches go. And on the right, you'll see the brush that's being used to clean that bore out. That brush, the shaft of that brush is harder steel than the punch guide. And so if that tool is not used right, then it causes wear. And this is not uncommon. People really don't realize how soft the turret that holds the punches and dies is, how soft that steel is, and how much that can hurt you. So having good, effective cleaning is incredibly important in order to get performance. So I want to run faster. I want to be more effective at what I do. I want to have a mentality, a pit crew mentality. I want to, I want that confidence, because if I know my parts are right. I know my tool is right. I know I've polished the tools. I know I've inspected the tools. I know I've looked at the parts. I know I'm ready to go. That's what set up with confidence means. And in order to get my quality product, that's how I'm going to do it. So when I overcome problems, I have to be able to separate the issues. Is it the ingredients, the powder, the press, the tooling, the operator, the environment? Got to look at each one separately and figure out what's going on. When I think of all these metrics here, flow, that is weight control, the variation or limiting the variation of tablet weight. Compression is thickness and hardness. Ejection has to do with the blend and the blend uniformity, and disintegration performance along with dissolution. So if I don't blend right, I'm not going to have good disintegration. I'm definitely not going to have good dissolution. So friability, stability. I have a spelling error here. Sorry, self-check. It meant shelf life. Sorry. And so on. So, look at static electricity. If you touch a bin and it zaps you, that's a message that now powders are going to relax. Static promotes segregation. Segregation causes flow issues and weight performance issues, and then you end up with poor quality tablets. So getting powders to perform right and having good processes to do that by is a very important part of the thing. Controlling the dust. I mean, this is the nightmare picture right here, right? We need to capture the dust. So when do you stop to clean? The right answer is, well, before now, and when you need to. So, we don't want to go so far. And what determines when you have to clean? How much dust is in that batch. The dirty little secret in our business is there's no such thing as a perfect blend. That means that every batch, every run is different. When every run is different, our performance has to react to that. And that's why I need a trained technician on the front line. The reason I need somebody on the front line is to interpret what's going on and take those three big components. How well are my ingredients running? How good is my machine performing? How well are my tooling acting? Did I do a good job? So when I see a picture like this, I see performance. I see a perfect die table. I see good installation of dies. I see a granulation that's got to fill and flow well. And in order to have good content uniformity of each and every one of those tablets at 6 tablet per compression event is a huge statement. So I know there's a lot of information and a lot of what our plan here is to put some of those things out there. How we react. So I'll ask you to, Karen, I'm going to turn over the controls to you so we can start responding to our participants here. Thank you, everyone, for the opportunity to spend a few minutes with you. And again, I think this presentation could have been 3 days, not 35 minutes. But thank you.
Thank you, Mike, for fitting so much into that presentation. We have a lot of questions coming in, so we'll get right to them. I know, Mike, actually you spoke a lot about constant visual inspection. I think this is a good question related to that. Is there a machine that can inspect tooling without dependency on visual inspection?
I don't believe so. I cannot imagine wanting to rely completely on a non-visual inspection. I can get it, but to my knowledge, the answer is no.
Okay. I would like to know the effect of lubrication time on tablet disintegration and how to determine the optimum lubrication time.
Wow, that's a loaded question. Karen, did you come up with that one?
Yeah, I thought I'd throw you a curveball.
Yeah, well, no, you didn't at all, because the lubricant, that is the mold release agent in the formulation, one of the most common ones is magnesium stearate, are like little platelets, and so the effect of the lubrication on disintegration and dissolution profound, because depending on the lubricant, but if we use magnesium stearate as a good example, magnesium stearate, first of all, for the most part, is not soluble in water. So if we over lubricate, that means if we blend too long, those platelets spread and surround the active ingredient, and they do a couple of things. First of all, they don't necessarily hurt disintegration, but they really hurt dissolution, because if the lubricant gets around the particles, then the particles can't go into solution. So let's define disintegration and dissolution. Disintegration is the amount of time it takes the tablet to go back into particles. Dissolution is how long it takes those particles to go, or the active to get into solution. So our expectation of a lubricant in a formula, a mold release agent formula, is to help make the tablet, to put a very small quantity into our blend, so that the powders don't stick to the tooling, so we have good ejection. So if it's true, if we blend improperly, or we overblend, is what that's called. If we put too much in or blend for too long, that can definitely impact how the tablet breaks apart in disintegration and how well it performs at dissolution. So thank you for that question. I think it's a great question that is a challenging situation for many, if not most, companies. Next.
This one plays off that a little bit. How do you identify if it's blend the machine or the tooling that isn't performing right?
Oh, I think that's a wonderful one. Great question. So yeah, because that's kind of my theme, isn't it? I talk about the press, the tooling, and the powder, but how do you separate the three? Well, so that's kind of why I approached that second slide or third slide in. I said, look, if we look at the setup operation, the disassembly, inspection, repair and replacement of parts, preventive maintenance, and then cleaning, and then we go through the cycle again. So the cycle helps us. So when we, wherever we get on this procedure, let's go through just the setup. So if I have properly inspected my tools and polished my tools, punches and dies is what I mean by the tooling. If I've correctly polished them and inspected them, so I know they're good. A lot of companies don't inspect them all the time. They're not 100% sure. I've seen a lot of companies recently that are inspecting but not really inspecting right. If I know I've inspected right, and if I know that my parts are good and they're clean and they're lubricated and they're functioning, and I've tested my machine and calibrated my machine, and I put all these components together, now I know that my tooling is good. Now I know my press is good. Now it's a matter of fitting performance of the powder to those two items. So then I can say, okay, there are things I can do to tooling or things I can do to the press to help compensate for powder performance issues, but we're always working against powder performance. Another way to say this would be how many powders can run as fast as the press can go. Like the press, some presses can go over 8 or 10,000 or more, way more than that. But how many powders can run that fast? So it's not the limitation of the physical apparatus, it's the limitation of the powders. And so when we start to optimize, how do we do that? We're going to optimize by first looking at weight control. How good of weights can we get? And then the hardness, and go right down the list of friability and disintegration and dissolution. Look at everything in the tooling performance. So as we go through this criteria, we get more and more performance related, how it relates to the tool, the press, and the powders. Hopefully that answers the question. Thank you.
I actually have a question related to that. I'd imagine there's different. Well, it's my question, but I'd imagine there's different operators in charge of these different areas. The tooling, the machine, the blend. I mean, how are they communicating to each other? That, you know, how are you assuring that each step of the process is done correctly?
Wow, I love it. That's such a challenging question too. I mean, that's extremely insightful. So, and that's, you know, sometimes part of the problem is really connecting all these dots together to get real overall performance. And so that's what we call it takes a team. I mean, that's what, you know. So there's a lot of people a lot of companies that have islands of operation where the guy over here does the tooling, and the person over here does the quality checks, and the person over here does the blending. And so, hey, you know what? It's a difficult thing, but most everybody who's making tablets out there are making tablets, and they've got competitors. And so your team doesn't get to see that other team making the same stuff. You don't get to see that this is a race, a performance race, and a quality race, but it's there. And so, if you know, when I go around the world and they get to see some of these different operations, the ones that really perform, not the survivors, but the real performance ones, those teams are talking to each other, and they're relaying performance issues and what's expected and how it went. And you know, the tablet press, the term that I've used for years is tablet press is a report card for everything that happened in the whole operation. So you know, if we're not making a good tablet, it's telling us. Now we have to interpret where that problem came from. I think that's my
That makes
best
sense.
answer.
In your extensive travels, what is the most common mistake that you see on the plant floor in regards to tableting?
Oh boy, I got a list here for you, but you know, interesting conversation here that I'll bring up. Let's talk about defects in regard to your question, because I could go off. I already kind of explained that one of the most common problems is really not effectively inspecting the machine, identifying problems, repairing the problems to get your machine back going. So we took care of that, but let's talk about defects. One of the most common defects in our business is sticking. Sticking or picking, which means that some of the particles that instead of sticking to the tablet, they stick to the faces of the tooling, the cup, within the cup, the upper punch and the lower punch. And so, and picking kind of refers to particles or granules sticking within the islands on the logos or tooling. So if it's got a 0 or an 8, those those little islands get loaded with product, and there's lots of ways to solve these problems. But so defects are a huge challenge, and one of the biggest challenge is sticking. But one of the interesting things in our business and our industry that fascinates me and really can be solved is that when we clean a machine, we take all of the lubricity, all of the lubricant that was in the formula. We take that all off the steel parts. So fundamentally, we have a piece of steel that's naked, that is cleaned so good that anything you do with powder is going to want to stick to the steel. It's kind of the equivalent to me of trying to cook some eggs in a frying pan without first putting some butter or what they call it, seasoning the pan, or something between the product, the egg, and the steel. And so that's actually when we blend. One of the purposes of having a mold release agent, a lubricant, is so that as the powder tumbles through the machine and across the feeder, across the die table, across the faces of the tooling, that the magnesium stearate or the other lubricants are attracted to the steel, and they start to create the mold release agent impact. But here's the problem. The problem is when we first start up a machine, the machine's so clean that it takes a little while for that lubricant to get distributed to really do its job. So most companies lose a lot of money at startup because the powder's sticking to the tools. Well, of course it's sticking because we just cleaned. And if we had somehow, and there's different ways to do this, pre-lubricated or seasoned our machine. So we go through normal cleaning, we clean the machine, and we can use the granulation to actually literally rub it on the machine. And we're trying to get the lubricant out of that, put it onto the faces of the tool, clean it back off. What we're trying to do is we're trying to season the steel. Some companies actually allow their setup people to use from the same lot the lubricant, a small quantity, and actually wipe it on steel surfaces, the die table, the punch faces. The companies that are doing that are having tremendous performance. I think the argument for risk is that there's a concern that there might be a concentration of just magnesium in one particular die station or a tool station, and a tablet could be out of spec. But those initial tablets are always rejected anyway. I mean, so the potential for that to happen is next to nil, is extremely remote. I'll never say impossible, but highly unlikely, because the first several revolutions of a press are rejected anyway. So if you did that, we would get better performance. So Karen, tell me if that was clear. You get my point.
Yes. And you must have, that you were exactly accurate in that being a common problem, because there's actually two separate questions asking about strategies to prevent defects for formulas that are prone to sticking. So.
So it's a challenge. So I throw sticking into two categories. The one I just went over is what happens when you first start up with it. And I just explained that sticking occurs because we didn't prep the surfaces. We're waiting for the powder to distribute its lubricant. And so what people usually do is they load up the machine with powder, they run, and as soon as they start running, they're sticking naturally because there was no lubricant. So they stop and they clean, and they take the tools that they already polished and they go polish them again. Well, basically what happened was we just distributed the lubricant that was in the powder. So now the surfaces are seasoned, and you didn't really have to take the tooling over and polish it. You could have just turned around in a circle and put it back on the machine, and it would have worked anyway, because now the mold release agent is distributed. So that's at the beginning of a run. So the other time that sticking occurs is steering operation. So, a lot of times sticking occurs like an hour or 2 hours into the run. Well, what's going on there? Well, that's a totally different thing. Um, so for a lot of products, um, so we can categorize a couple of things here, but for a lot of products, they start to generate a little bit of friction and a little heat over a period of time. And many products produce this really thin film, and this film starts to build up and then starts to pick. And for you folks out there that are running products, when you see buildup on the die table or you see a thin film on the tools, that's as a result of either the waxy nature of the ingredients, moisture within the product, just the nature of the ingredients. Some of these things are kind of gummy, and so they're very, very temperature sensitive. They're sensitive to speed. So sometimes we can get just a little bit too much friction. We could be running along fine and all of a sudden get in trouble. If you watched close, you might have seen it coming. You might have seen like the faces of the tools start to get a little bit more buildup of extrusion or this thin film on the surfaces. You might have seen a little bit more extrusion or flash on the edges of the tablet. You may have seen an increase in ejection force. Sometimes if you take a look at the sides of a tablet, what you want to look for is on the band, on the side of the tablet, area that contacts the die. You want to inspect that closely because we want that to be smooth. We want it to be shiny. We want to look at that surface all the time, frequently, because if we start to generate friction from ejection, you'll see that instead of being shiny along the outside diameter, there's stress lines. There are vertical lines that are showing that the ejection force is increased. So when that happens, that's just a reaction to trying to get the machine to perform beyond the limitation. Sometimes it goes as far as, well, that's the point at which we got to stop and clean, pull the punches, wipe them down. Sometimes running slower is better, and being very sensitive to maintaining very, very accurate weights. The more accurate the weights are, the more accurate you're going to get good hardness. Because when sticking occurs, sometimes it occurs because we're a little bit too hard or extruding product out of it, and sometimes it happens because we're not quite hard enough. And so if you don't have good weight control, that means that when the weights go up, the tablet's harder. When the weights go down, the tablet's softer. And so the greater the accuracy of weight control, the greater the control over sticking problems in the middle of the run. So that would be the quick answer to, or one way to look at, ways to overcome sticking.
Okay. Another question. Are the black lines on the sides of tablets caused by ejection problems? How can I solve that if I get it at the beginning of the run?
Oh, yeah. So I think what this question is a little bit about is that sometimes no matter how much you clean or how good you clean, the first couple of tablets that you make have some residual on it. So even when you clean well and you go through with a detergent, sanitize, you wipe down with alcohol, there's still a little residue. And when the first couple of tablets you make, when you push the tablet out of the die, you go, oh my God, there's little, these black lines on the sides of the tablet. We must not have, it's not, you didn't do a good job. There's just residual in the solution. If that goes away and immediately, that was just residual. It's gone. The way to solve that problem is to take another look at your cleaning procedures and go one more step. That is, kind of the white glove approach. I believe in cleaning these parts. I have a three-step process. I like to use a brush to break up the problems and the oils and the greases, and use solution to clean for those things. And then I like to go back through and use a second brush, a different brush, and I use, like, at the end I like to use a third brush, and that's a clean brush. That's a dry brush, and that should never have any black or gray or residual on it. So if you really did a good cleaning job, that brush will always be clean when you're done. If it's not clean when you're done, then the cleaning wasn't effective. The reality, though, is I go to a lot of companies, and it's almost embarrassing. It's like, oh, where's that brush that we used to clean the other day? They got one between three machines, and nobody seems to be able to find it. So the dirty little secret in our businesses is that we've got all this concentration on good operation and making sure that things are set up right, but the effectiveness and the efficiency of cleaning isn't always and I don't mean to offend a lot of people out there are unbelievably good cleaners, way better than me, but I think even those people know that that this is an area that's a weak area in a company. It's not that the technicians don't have the ability. It's oftentimes they don't have the tools to do their job right, and have enough brushes and have everything they can do to get things done. So I think the problem with these black spots was from residual, and it's just showing that the cleaning could be better.
Okay. I think, unfortunately, we've run out of time. If everyone wants to continue to submit their questions, we'll organize them and get them over to Mike and try and get you answers. Thanks again, Mike, for fielding all those questions and for your presentation. A final reminder to the audience. Final reminder to the audience to please let us know your thoughts on this presentation by answering our brief survey that will appear on your screen shortly. Your candid answers are appreciated and will help us craft our future events. Remember, this webcast will be available on pharmamanufacturing.com. Feel free to share it with colleagues or log in to view it over and over. We also encourage you to visit pharmamanufacturing.com to gain access to even more tools and resources aimed at helping you achieve success. On behalf of Pharma Manufacturing and the folks at TechCeuticals, thank you for your attendance and have a nice day.